My slides are generated by Emacs. Thank you, thank you. Before I begin, I'm going to let you into a little secret that you won't know about functional works. Every morning, Charlie at the morning stand-up drills them in big O notation with the fact. Yeah. The earth moves. Yeah. Elm. Who's heard of Elm? Hands up. Who hasn't heard of Elm? I can tell you about Elm, particularly you. Yes, good. Right. Elm. What's hard? Let's talk about hard things in programming. Let's start there. I put it to you that there are two major kinds of hard in our life as programmers. And they split quite neatly. At the back end, you've got computationally hard problems, which are keeping us interested at the moment. You've got things like, distributed transactions are genuinely hard. Distributed databases across geography. These are genuinely hard things which are backed by theories which say some things are impossible. Deal with it. The cat theorem, for instance. That is one kind of hard we face as programmers. There is a second kind of hard which concerns me particularly, which is front-end programming has a very different kind of hard. You have so many things you have to manage as a front-end programmer. You have to basically mirror what the back-end does and make it look pretty and make the errors look nice. You cannot throw a stack trace on the front end if you know what you're doing. Then you've got to deal with users, who are the most complicated thing on the planet. Then you've got to deal with people in marketing, who are the most complicated thing in the universe. And you're constantly in flux. Your user interface is constantly evolving as people come back with feedback. It changes way more than the back end. And standards are rising, believe it or not. The things we expect from user interface today are way ahead of what we expected a decade ago. Quite a way ahead of what we expected 3 years ago. The front-end demands are evolving rapidly, and it's a constantly moving thing. And that is the other kind of hard we face. And I have bad news for you all. Our tools aren't keeping pace on the front end. They really aren't. We mostly, on the front end, program with a language that had an experimental design phase that lasted 2 weeks. This is not good. This is not good, but I have hope. I have much hope, and I'm here to deliver you hope and pizza. Well, they're delivering pizza. Elm, believe it or not, is the hope I offer you. There are lots of very interesting languages coming in the front end to solve the JavaScript problem, but tonight I'm talking to you about Elm, as you know. Elm is a functional language, which I expect everyone in the room to think equates to goodness. I don't need to justify that to you. It's a variant of Haskell. Both non-Haskell programmers and Haskell programmers say the same thing about it. Non-Haskell programmers say, it's like Haskell, but it's simple. And Haskell programmers say, it's like Haskell, but it's simple. It's written in Haskell. It compiles down to JavaScript, so it's a transpiled language, which is a word we all love. It's easy to learn. Some of you have heard me say this, but I have a bet with the world that you will learn Elm, how to make a whole app in Elm, faster than you will understand Angular directive scope. Because you can't understand it until the user starts interacting with it. It's non-deterministic. And it's structurally quite simple. It is simple both in the common or garden sense and the rich Hickeyan sense. And it has cool features, which I'm going to tell you a bit about. It's got friendly static typing. It's actually got static typing, and it genuinely is friendly. And I might show you how later. It has pure rendering, this idea we're getting from React, popularized by React, I should say. One-way data flow, an idea popularized by Flux. It has a particularly nice implementation of that. Immutable data structures, I'm preaching to the choir. Pure functions, again, control over side effects, tight control. And this, to me, is the essence of functional programming. Tight control over side effects. Eliminate them where you can, control them where you can't. So this is all good. It's also got a fast build tool. It's got a great package manager, which is nice to work with. It's got enforced semver, So if something says it's had a minor point change, you know it actually has because the compiler checks what semantic version the library should be. Cool. Loads of cool stuff. What I want to do is give you an overview of how an LMAP is structured and tell you why it's different and show you some examples and some code. We'll see how we get on with the theory stuff, whether you want some concrete stuff or more theory, you can tell me. So, every LMAP basically boils down to 2 data types and 2 functions. 4 things you need to know in your head to build an LMAP. I shall tell you what the 4 things are. The first is a model of the world, right? You need to know what's the current state of my app. This is a very simple example, which is tiny on this screen. Who at the back can see this? Yeah, okay. So here I'm just modeling a login form, basically. I've got a username, it's a string. I've got password, it's a string. I've got the last and I've decided to store the last error. So if you hit the wrong password, we'll get an error back from the server, and we want to display that at the top of the login form. Vanilla stuff. This is the syntax. That's all I'm going to say about syntax. The second thing is you need to say, well, what can happen to my app? What are the events? What are the actions that can occur? What new things occur to move the app forward in time? And for a login form, it's pretty straightforward. You can say, I want to change the username that we're remembering. Someone's typed something in. I want to change that, and here's the string I want to change it to. Similarly, password. Someone can hit the submit button, and the server can come back and say whether that worked or not. Right? So there are 4 different kinds of things in this very simple login app, and we've modeled them all there as data. Those are your data types. Then we need a function that says, well, if I've got an action coming in and I know what the current state of the world is, how do I move that forward to the next state of the world? When someone clicks submit, what do I do to change the state of the world? It's just a function. It's a pure function. This is important. Here's an example of that code. So I look at, please put your hand up if you want me to explain this syntax in detail. But basically it's saying, that's the type signature, and then I'm going to look at the action to decide what to do. And in this case, when I get an action coming in saying change the username to this string, I'm going to update this model so that the model's username is whatever that string is. Yeah? Everyone happy-ish with that? Ask any questions during the talk. I'm happy with that. OK. That should be the update function. It's actually a little more complicated than that, because sometimes, like when someone hits submit, we're going to need to go off to the server and cause that to generate a future event that says the server said this, a future action. So the type signature for your update function is a little bit more complicated. It's not take an action in a model and return a model. It's take an action and a model and return a model and possibly some side effects which themselves will generate new actions. Let's have a look at that in code. It becomes clearer. So I'm going to change I'm going to have a submit action here that returns the model. When someone hits submit, we don't actually change the model of the world. We just create a AJAX post. And this somehow is going to return a login response action. Right? This is probably the most complex bit of code in here. So we've reached the high water mark. Okay. I can get a bit fancier than that if I want to. I can say, well, actually, we'll do exactly the same, but I'll put a field on the model that says loading. And when this submit action comes in, I'll say, we're loading, and I'll disable the form, and that will do nice rendering. That's an example of when we might want to do both things. Yeah? So that's 3 things. Model, action, a function that takes actions and models and moves the world forward. And the 4th is rendering. Because we've got this lovely model of the world, we need to actually show it to the user. Ideally, as a functional programmer, you might expect that's a pure function from model to HTML, right? Here's an example of that. Here's my login form. This is, if you know Bootstrap and you've used more than one templating library in your life, you can probably read this. You go, oh, it's another templating syntax. But yeah, I can see there's a form here. And there's an input with attributes, and another input with attributes, and a button with some Bootstrap classes. Oh, and I've got fancy. I'm disabling this login button if the username or the password is empty. Simple validation. That, in an ideal world, is what your rendering function would look like. It's slightly more complicated than that, because in HTML land, a user interface is actually a source of events as well. It isn't just a display mechanism. Someone can click a button and generate an action, like clicking the submit button and generating the submit this form action, right? So Elm has this thing that says, here's a place you can send actions, and I will route them through to your update function eventually, using this address of actions. It's typed, it's checked at compile time, it's side effect. Is it side effect? Yeah, it's tightly controlled. And this is how you use it. And on change sends to this address a username action with the value of that event. I don't think it's too... Everyone happy with that? Anybody unhappy but unwilling to put their hand up? Ooh, it's a tricky one to answer. That's it. That, in a nutshell, is Elm's architecture. You've got type of model, type of action, an update function, and a rendering function. And you are largely done. Pretty much every Elm app looks like that. Now we have a brief pause while I wonder what my next slide is. Oh, yeah. Do you want a simple demo? I said, do you want a simple demo? Yeah, thank you. So, tell me when that's large enough that you can read it. You see that? Yeah? So, this is, let's see, it is 51 lines of code, and this is about the simplest app I could put together this afternoon. Our model is a counter of integers. You can almost guess where this is going, can't you? Which is great, right? We've got action, which is increment. And you can probably guess what this app is going to do, which is actually a nice property that holds as it gets larger. You can look at the model of the world and look at the possible actions and make some reasonable guesses about what this is going to do before you even get into the rest of the code. Initial state of the world, the counter is set to 0. There are no side effects. You might have startup side effects, but there aren't any for this. This is my rendering function. And then this is my update function. When we get an increment action, we increment the counter. And we don't do anything else. We don't trigger off an AJAX request or anything. And then this, I'm not going to explain because it's boilerplate stuff that you only have once in an Elm app. Go read the docs. Isn't that a brilliant excuse?
I have a quick question.
Yeah, sure.
If you have multiple side effects, is that just a list of side effects?
Yeah, there's another function which you give a list of side effects to, and it turns it into a single batch. And it's called batch. Who's ready for this incredible demo? Don't make me do it again. So, yeah, rock and roll. Perhaps a bit more exciting. Would you like to see me change it? I should give you a live demo of what it's like to code. So, let's say I'm going to change this to. Let's change that button to one that increments by 1 and one that increments by 5. Yeah? I will compile that, and I get some type errors. It's not going to blow up at runtime. So this is saying, it's looking through the types. I'm calling it like it's a function, but actually it's just a standalone action. It doesn't know what to do. The answer is, I've changed this increment thing to take an integer, but it doesn't. If we look at the definition of increment, it doesn't really have any content to it. So I'll just change that, like that. I'll recompile it. Now I've got another type error. And that's here. This is saying, I've gotten the increment in. You've said it hasn't got any arguments, but it does. It has one. which is the number. So put a number there, change that to n. It says it will now run. It's compiled, so in theory, it runs. That's it. Caught all my errors at compile time. Probably say, I should have said at the start, actually, this is a rehearsal for a talk I'm going to give my daughter. As soon as she's old enough to talk. My wife thinks we shouldn't, but you know, I think sooner or later someone's going to tell her that the type of undefined is not a function. As parents, we should control that message. That's my simple demo. Where the heck are my slides? Where is it? Hang on. Oh, right. Gonna read. Let's just regenerate them from scratch. Yeah, there we go. There we go. We're back in the game. Who saw that coming and didn't warn me? Yeah. Okay. So, I'm not sure about time. I'm going to assume I've got all the time in the world. Someone can kick me off. So that's kind of an overview of what it looks like. I would like, if we've got time, I would like to tell you the big idea, which I think is a larger idea than Elm itself. I think Elm is great, and it's a really nice way to build apps. But there is a larger idea at work here that any language should be excited by, and we should be spreading and exploring. I'd also like to show you some real-world stuff so that you can see this language isn't just for incrementing counters. You can actually build some real websites with it. So I'm going to do the theory first. Yay! Everybody loves theory, right? Comparing Elm to MVC, you might think they're quite similar. And in a way, they are. Elm has a model, MVC has a model. Elm has a view, MVC has a view. And the update function is kind of like a controller. Kind of, if you squint. A big difference just in these types is that models and updates are decoupled. The whole thing is decoupled by using actions. So when someone clicks a button, it doesn't call code that changes things. It's genuinely decoupled by passing data between them. A button click generates some data. Somewhere else, some data changes the state of the world. Data, if you ask me, as a kind of functional aside, data is the only way that you can genuinely decouple things. But again, I'm preaching to the choir. So on a surface level, they're kind of similar, but I think there's a really, really big difference here that's really important, as my slides tell me. This is MVC when it's simple. You have a model at the back, and you have a view at the front, and you have a controller in the middle, and the demo docs work really nicely, and everybody thinks, yay, this is going to work brilliantly. And then it gets a bit larger, and you go to your WYSI GUI editor, and you drag some components in, you wire them all up, and you think things are still simple, because you've got this astonishing ASCII art diagram. I'm particularly picking on Objective-C, iOS here, but that's how most MVC things basically work. They may wire them all into the view, or they may wire them all into the controller, but this is the way nesting and modules work in MVC. You stick one of these as a subcomponent of part of the other one and build up your tree. Now, to some people that looks great, but we're all functional programmers, and we know that something's gone wrong when we look at the types of these things, because our view, which in Elm speak takes an address and a model and turns it into HTML, and is now takes an address and a model and does anything it likes. Look back at this diagram. This view doesn't just generate HTML, it sends AJAX requests. You've got a view function here that writes to local storage because of this thing. This is crazy. If you look at it as a functional programmer, views can have any side effects they like because of the way we've nested components. Because side effects always bubble up. If your function calls something with side effects, then your function has those side effects. and so on all the way up the tree. Haskell programmers know this in particular. The side effects pollute all the way up. This is wrong. This is the big idea, why things always get complex. We're doing it wrong, and Elm is doing it right. And this is how it's solved. Make separate trees of your separate components. Make a nested tree of your model. Take all your submodules and look at their models, nest those together to get one large model. Take all your controllers, nest those together. Take your views, nest those together, and let the routing take care of passing the messages around so that you end up with just one supermodel, one super view, and one super controller, but the app is structured as separate modules. That way, view functions remain view functions. Models remain pure data. You get all the advantages of nesting, but you don't pollute the functions. And again, preaching to the choir, but we know this as functional programmers. If you control and eliminate side effects, you keep your sanity. Is there anybody? No, you don't want to disagree with that.
How can you create usable components with this architecture?
So every module would expose, let's say you've got a date picker. So it will expose a model that represents, maybe I've got a date, I expect. And it will ship with a standard rendering thing that can turn that model into HTML. But you might swap it out for your own custom rendering. And then it's got an update function that can handle all the possible actions that their UI represents, right? As that comes to you, you'll basically get a tree thing that says, I should have drawn more ASCII art, I'll put it here. This controller will get an action in that says, I've got an action of type calendar. And the calendar has a payload, so it passes it down. And this payload is, I've got an action of type day view. That's got a payload of date picker change. You process it here. This part of the world advances, and you're off. You're just, for each step of the chain, you're just handing off the action until it gets processed. And then you end up with the same advantage that you've got. You can look at the submodule and know all its actions, and you can look at the submodule and know its data. You can swap out the rendering if you want to, and still use their same update, which is nice. Especially if you used enough components where you like the way they work, but you don't like the way they render. Or even more commonly, you like the way they render, but they work like... sorry, any more questions?
What's the assistance to what if you store offline like a database somewhere? Is that possible? Yeah?
Well, I mean, it's the same as any front end. You're going to want to push it to a server, and then it's not your problem. The people I've worked with in the room who did the back end, it's not my problem. So yeah, so that I genuinely think this isn't something I've come up with. This is Elm's architecture, but I genuinely think it's a solution to the complexity problem in MVC, and we should be looking at it in other languages that need MVC type solutions. Big idea. Yeah, Elm is great. Give it a try. And if you're interested, I run a monthly hack night where you can come and practice in West London. So search for West London Hack Night and join me. But yeah, try it out. It's great.